Hi students, in this video I'm going to review the questions that you have on your view of multiplying rational expressions. This is a first example, and to simplify these type of problems we want to start by factoring. So you want to factor everything, numerator and denominator. So this trinomial on the top needs to be factored into two binomials. This right here, binomial, is a difference of squares, where you have something squared minus something squared. So that's also going to be two binomials. This numerator at the top cannot be factored, so you just write it down. And this binomial also is a difference of squares, so something squared minus something squared. So that's going to result in two binomials. So to start with the trinomial, we're going to need to do the x. And we're going to do a times c on the top and b on the bottom. A is 1, so 1 times negative 12 is negative 12. B is 1, so that's a positive 1. Then you make a list of what are the factors of 12. So 1 times 12, 2 times 6, 3 times 4. As you do this combination, you notice that 3 and 4 give you a 1 if you were to subtract 4 minus 3. So we're going to do 4 minus 3, and 4 times negative 3 is negative 12. So these work, positive 4 and negative 3. And what we're going to do next is, again, you want to get into the habit of dividing by a. If your a value is 1, though, they don't change. So you're just going to write x plus 3, x plus 4, x minus 3. So those are the factors for the numerator. Next, if you look at this binomial, and we said it was a difference of squares, we can say that we can multiply x times x and then 4 times 4, and they give us x squared and 16. So now we proceed by writing x and 4 right here in your binomials, and 1 with a plus and 1 with a minus. So those are the binomials for the difference of squares. So similar to that, we have this problem. X squared comes from x times x. 25 comes from 5 times 5. So we're going to put x and 5 and x and 5. And one's going to be a plus and one's going to be a minus. So that was the process of turning what you were given into factored form. Now that you have the factors, we want to simplify. And by simplifying, it means that we're going to look for one-to-one ratios of numerator and denominator. So for example, the x plus 4 and x plus 4 create a one-to-one ratio because they're the same factor on top and bottom. We also have x minus 5 and x minus 5 over here. So what's left is x minus 3 in the numerator and x minus 4 times x plus 5 as the denominator. These are factors. So this is your factored form. Be open-minded that you may have standard form as well. So we're going to do x minus 3 as a numerator because nothing changes. And we can erase the parentheses because we're not multiplying times anything. Then on the denominator, we have two binomials. And when you have two binomials, you either do the process of FOIL, which is the loops of this term times these two, and then this term times these two. Or you can also do the box, the area model. X minus 4 on one side, x plus 5 on the other. So whichever you decide, just make sure you do it correctly. We're going to do this one because just the majority of the students picked that. So x times x is x squared. X times negative 4 is negative 4x. X times 5 is 5x. And positive 5 times negative 4 is negative 20. Then you have like terms right here in the middle diagonally, and you combine those and you're going to get x squared. This is a positive 5, that's a negative 4, so 5 minus 4 is 1. So we're going to say plus x plus 1x and minus 20. So the answer ends up being this, if you want it in standard form. All right, let's try one more problem. This problem is showing you that we're still multiplying and it's already in factor form. So you save yourselves the steps of factoring. So if we were to follow the steps of factoring is done. Next, we're going to simplify. So by simplifying, it means that we're going to dash out the factors that are exactly the same on top and bottom. So for example, x minus 4 and x plus 3 and x minus 5. And that leaves you, oh, actually x plus 5 as well. So that leaves you with just the numerator of 1, because there's nothing left in the top. And then the denominator of x minus 4, because there's nothing left other than this factor in the denominator. And this is your answer. I hope these two examples helped you try the next two problems, and good luck on this topic.